Good morning. Well, it's morning for me. Almost noon. Almost not morning anymore. Ladies and gentlemen, welcome back to the Yield Foundry. This is going to be a very short film, even short for me, because even though I might get rambling on to just a smidgen, I was asked specifically about the flask that I made. Now, I made it out of scrap that I had around here. The sizes of flasks in the United States Navy foundries. I mean, the flask, how many flasks you had and the different sizes of flasks you had depended on a couple of things. Number one, exactly what you make. You know, what do you make all the time? All right, you can make temporary flasks for a 1 in a million job, or you can have the typical foundry flasks that, now these are inside measurements, okay? Because if you have a snap flask and you ram it up and you take the snap flask away, you're going to have a big chunk of molding sand that's going to have a specific measurement. Pardon me. And the smallest flask that we typically had on almost any command that I was ever at was a 12-inch by 12-inch by 6-inch thick flask, okay? But those are all inside dimensions. Outside dimensions, it depended on whether it was made of wood, made of steel, made of aluminum, you know, depended on the flask you bought it, the company that you bought it from. But the thing that was all in common is that the inside dimensions for the smallest one that we had was 12 by 12 by 6 inches per half. You know, the cope and the drag. Cope would be 6 inches thick, drag would be 6 inches thick, and you know, you could buy other flasks or make other flasks that were a typical like 12 inches. Well, it was 12 inches by 12 inches. Then we had 12 inches by 14 inches long. Then we had 14 inches by 14 inches. You had, I mean, you know, any number of sizes. It all depended on what you're most likely to be making, okay? Now, after I made my molding bench, it was, I mean, what good would it be without a flask to be able to ram up the sand inside, right? So I'm going to turn you around and just point the camera towards the things that I'm describing so that you can see. It's just going to be a real simple film on describing of what I made, how I made it, and so far they've worked real well, okay? So here we go. I'm going to turn you around. There you go. Okay, this is the only flask, the whole flask that I've ever made so far. Okay, I'm limited in the amount of sand that I can ram up inside here because, well, there's my sand. That's my entire inventory of sand right over there. Right now I'm letting it dry out so that it'll be a lot simpler for me to replenish the moisture in the sand the next time I have need to use the sand. That's how I let it dry out, okay? Now you can, as you may have seen in a past video, you can take the sand that you just knocked out. Let's say you just poured a mold, you knocked out the mold, you've put it through, in my case, this is my muller, to knock it into its smallest pieces, and then you could go ahead and get a sample, find out, I mean, you know, weigh that sample, put it through an oven, dry out all the water, weigh it again, and then you'll find out how much you have right then, water-wise, in the sand, and then replenish the moisture that evaporated. You know, back up to the amount of moisture that you need it to be. Okay, I don't make so many things that I bothered to use that technique. So I just let it, I make a mold, I pour it, I break it out, put it through, the muller, and put it in there, let it dry out, and the next time I need it, I put it, back in there into the muller, and weigh out the amount of moisture that I need and introduce it into the sand for the next mold. Okay, now back over here. The inside, the dimensions of the flask, from corner to corner, 12 inches. From corner to corner, 12 inches. And from top to parting line, okay, that's 6 inches. Some of the other 12 by 12 flasks that we've had, the drag was 8 inches, but 6 inches of sand for what I've ever made so far has been just fine. Okay, this was made out of scrap 2 by 6. Okay, so it already had the 6 inches that I wanted for the inside, from the top to the parting line, and that's perfectly what I wanted. And then all I had to do was just cut them to size for butt or lap joints, where you just had the inside was made up 6 inches, 12 inches. This inside made up 12 inches, and then this board was cut long enough to overlap this side very nicely, and when I put it together, I used screws just to draw them up tight. Okay, and then on the inside, to stiffen up the whole assembly, I got 1 inch angle irons with holes in it. This was part of a shelving unit that I had taken mainly the pieces of and cut them down so that this would not only stiffen up the whole assembly, but it allows the sand that you glue it and nail it, whatever. But I mean, you're just using scrap here, okay? Or you can make your own on your table saw, and this works real well. Okay, I've seen where the people would take this and have this in less. It's not so much a rail shape, not a straight shape, but more of an angle. Having it slightly thicker down here than it is up here, and then once you make the top half and you sit it on here, and you're getting ready to put these pieces on here, I mean, these you bring up against whatever pin you've manufactured and bring it up, fairly close, because you absolutely don't want this thing to wiggle, you don't want this to tilt, you don't want this to be able to be cocked, so this has got to be as close as possible. But you'll find if you do it too close, it's very, very hard to easily take it apart and put it back together. So you're going to wind up, fiddling with that a little bit, okay, to give yourself a little bit of a gap, because unless you're using some kind of mechanism to lift this thing away, you're going to be the one who's lifting it away. And if you make it too tight here, you're gonna be struggling. The more you struggle, and the more that's hanging up here, you're gonna make it fall apart. So give yourself a little bit of a gap here so that you can easily open. Well, let me see. Or I'll put it like that. Okay, now. Excuse me. Okay, let's say I've struck that off. I'm ready to. I've done everything up here. I've vented it and I've made my splash basin and all that good stuff. Now it's time to take this apart and to work on the individual halves, all right? Well, what you need to do, you don't want to have a handle here and you have to toss it up. What you need to do is you need to easily raise this up so that if there's anything hanging beyond the parting line, it won't just fall because of the jerkiness of your bringing this apart, okay? So make it good enough to where your fingers can touch the bottoms of these and your thumb can touch the top of that. I've got it done that way. I'm never going to take it apart if I have this locked. Okay, got the fingers on the bottom of here, the thumb on the top of there, and then you just easily lift it up. Then I would go over, set this on the side, and then I'd work, okay? Now let's say I've finished it all up. You don't automatically boom like that and then put it together. Because if there's any looseness at all in your sand here, as soon as you do that, bang, it's going to fall. Let it, you're going to have it like this for another second or something like that, which allows everything to settle and start to fall, okay? So if you've got it to where you've got a little bit of hanging, you don't really want to, you know, take a chance. You get it, bring it over, slowly, easily, without jumping up and down at all. Slowly, easily, bring it, line up on the pins, and easily bring it down. Once you put this back together, as long as nothing has fallen, your mold is ready, and you can pour it off, okay? Now, what happens if you've got something that you're making that needs extra sand? Okay, let's say you just need a little bit more here, okay? You've got plenty sand down here. The parting line is perfect for this mold. You just need a little bit more sand there. Well, anybody who's seen seen my videos knows that I've made a bunch of cheeks. A cheek typically is used here, down here at the bottom, to raise that up, okay? But if all you're doing is just requiring just a little bit of a sand, maybe part of that mold cavity is just this much into this area, okay? You do once you rammed it up and you smoothed everything out, you know, you're casting in this theoretical idea. Your casting is sticking up, let's say that much, past this, okay? You need to have at least half an inch, if not an inch, of sand covering that, okay? So that it's nice and strong and that it's going to be solidify at the same rate as everything else. Well, I've got this casting I'm trying to make. Unfortunately, a portion of it is sticking up past the cope's parting, you know, the top of the cope. Not a problem. This is up like that. Bring this over here. After I've slicked everything down and all I've got is just sand and this little bit of this casting, you know, sticking up out. All right, this is all slicked down and parting powder put on there. All you got to do is take that, ram it all up, and then go from there, okay? Most of the time, this cheek will be in this area. You know, you don't always use cheeks. That's for a special occasion, an unusual circumstance where a cope and a drag is not going to, you know, be enough for the project that you're making. Okay, now I've covered the inside diameters. Okay, anytime you see a dimension for a flask, they're talking inside diameters. They're not talking, you know, how much it would be to make a box to ship this to you. Okay. Got the inside diameters that's going to hold all the weight. You've stiffened it. You've made wear plates so that it doesn't wear down. You made your alignment pins so that everything comes together exactly as you're taking it apart. Now, but if you have, let's say you're making something flat and you're going to be maximizing, see if I can find a darn example. You're maximizing the amount of, okay, yeah, this would be doing good. The billet that I made one time, okay, you've just poured, you know, you poured this and it comes in the bottom first and it starts filling up. Well, this is still liquid, okay? So it's going to have that same hydrostatic force being exerted down against the bottom of this, and this is going to make everything want to lift, okay? Especially like when it comes up to this point, this is going to have the tendency to try and lift. All that's got to do is lift 1/8 of an inch, and if the metal is hot enough, it'll flow in there. You'll never be able to, it's going to be like a dam breaking. It'll flow, the metal will get out where you're trying to pour it, and it's a very, very dangerous situation with all that very, very hot metal going everywhere. Okay, so if you have a flask which has only 2 parts, you don't want it to part at all, you can do something like this. A window lock that when you turn this the lock portion, this holds the cope to the drag, doesn't allow it to lift. Okay, that's how I've solved that problem. You can also, if you've got, you know, a flask that's a solid flask and it's not a snap flask where you're going to open it up and, you know, part this, and then you're going to have a mold that's got the sand all exposed. If you've got this situation, you can always put weights on top, okay? Like, for instance, let's see if this is big enough for me. Yeah, we'll try it. Anyway, sorry for getting you all dizzy. You got this all full of sand. You can take one of these and sit it on it like a typical mold weight, except this is just one of my workout dumbbells. But the weight of this 35-pound dumbbell just might be enough for this to not budge an inch or 1/8 of an inch, to budge a bit, not the least bit, and not leak out at the parting line, okay? If this is being sat, you know, let's say that this is where the pouring basin is. You don't really want this in the way of the pouring basin. You basically want it in the middle of this so that you have all the force being exerted on over the whole thing. But you also don't want this to be sitting on the sand, because what happens if this is heavy enough that you've got a good sized mold cavity in there and it crushes the sand and messes up your mold cavity, okay? But here we go. I got a piece over here. What you do is you get a piece of steel that's large enough, and you sit that on it, and the steel is resting on the wood, so that this force is being exerted against the steel, which is being exerted against the wood, which is keeping it from coming apart. Okay, there's your basic mold weight, and this is not being pressed into the sand, which might screw up your mold cavity. Okay, this is my only real flask, and I made a bunch of cheeks here, which can not only be used as cheeks in between here and here, but also can be used for stack molding, which is covered in another video previous to this one. Okay, so that's all I'm going to say about it. I had a person asking about more detail on how to make one of these, so I said, hey, you know, that's a good idea. I never really covered the details on how to make one of these. I don't remember. So I did a nice little verbal on how to make these, okay? So we will see you later, ladies and gentlemen, from here at the Foundry. Bye-bye.